All right, so this is going to be our first video in our next topic, which is going to be Open Shortest Path First, also known as OSPF, or that's the abbreviation of Open Shortest Path First. It is actually also known as link state. This is our other routing protocol that we're going to look at besides what we did with RIP. And so open shortest path has some similar starting starting assumptions in that each neighbor node is known and the cost to neighbors are known. So these are the same starting assumptions we saw in RIP. One of the first major differences from RIP is that we're going to introduce a new element into open shortest path or into our routing protocols, specifically what's being implemented in OSPF. And that is that we are going to add in some elements to improve how information is shared in the network in terms of how we learn about the other nodes in the network. And so the first thing we're going to add in is this element called reliable flooding. And the idea behind reliable flooding is that we are going to ensure that the way that we share information across the network is in such a way that we can avoid out-of-date information. And so reliable flooding means that a node is going to send link state information out to all its neighbors. That information that they will send out is going to be basically the ID of the node that created the link state packet, also known as an LSP. There's going to be what we call a sequence number, which is kind of like how new or how old is this packet. And then there's also going to be included into there a time to live, so that this packet will die eventually in the network. These first two elements are used in, and there's one more thing I forgot. It's super important. The fourth thing that gets shared in the link state packet is a list of directly connected neighbors and the cost of each link. And so the red ones are used for, red stars are used for routing calculations. The elements that are marked in blue, those are used as how we create the reliable flooding. The sequence number basically allowing us to be able to tell how new a packet is, and the time to live being able to terminate that packet eventually. And so the way that the flooding, so this is the information that gets shared by the flooding, so this is what's shared by the flooding. The way that the flooding process works is that a packet, an LSP, that link state packet, is sent out by a router. Whoever receives the packet will send back an acknowledgement. Often just referred to as an ACK. This is a way for us to get confirmation that the packet was delivered. So you can think of this as like mail delivery confirmation if you think of things in the real world. When this packet, when that LSP is received, the sequence number is checked. And if it is newer, store the information. If it is older, or the same, we dump the packet. And then if, continuing off of if it is newer, the router will send a copy of the link state packet to all neighbors. Except for whoever sent the link state packet. So in this way, we can get a form of reliable flooding if I was to look at a network like this. if, say, A was to send out link state packets, they would go like this. This would prompt both C and D to send an update. C and B would send updates to D. Even if D gets a packet and it sends it back, because the sequence number is basically the same, this will not cause B and C to flood backwards. And so this means that we've managed to implement a form of reliable flooding that prevents kind of a broadcast storm scenario where we are always generating link state packet updates. And so it is through the combination of these three, or is through the combination of this entire reliable flooding implementation that we can end the flood at some point. And so what we'll look at in the next video is the types of packets that can be sent and what those packets can mean for us. And then we will also start looking at the algorithm that is implemented through, or the algorithm that is used to implement OSPF's operation.